Greetings everyone. In this video we'll be looking at NCEA Level 1 Mathematics Common Assessment Task Algebra. So some of the skills that will be demonstrated in this video will be solving exponential equations, and I'll be looking at using prime factors. So some of the basic guidelines to solving exponential equations. The first one is you need to rewrite the bases as powers of a common base. Then you will need to substitute the rewritten bases into the original equation. And once you have done that, then you will need to simplify exponents using laws of indices. And in my previous video, I have already covered laws of indices. If you haven't already, please do check that one out. And finally, you will solve for the variable. We'll quickly have a look at the first example here. It says solve 2 to the power of x is equal to 64. Now, exponential functions will have the power which will be unknown. And this is written in the form base index, and if the power is unknown, we know that we are looking at exponential equations. So in this question we've got a base which is 2 on the left hand side. So what we need to do is we need to rewrite the bases as powers of a common base. So we will use 2 as our common base. Then what we have to do is we have to rewrite 64 as a common base of 2. We can do that by using prime factors of factor tree. So if we use the factor tree, so we can split 64 into 2 and 32. So if I halve 64, I'll get 32. If I halve 32, I can get 16. And in other words, 2 times 16 is 32, and 32 times 2 is 64. And then if I halve 16, I will get 8. Likewise, half of 8 is 4, and then half of 4 is 2. Now we've got all the prime factors for 64. In this case, it's 2 times 2 times 2 times 2 times 2 times 2, which means it's 2 raised to the power of 6. Or we can split 64 into 8 times 8 being 64. Then 8 can be split into 2 and 4. Likewise, 2 and 4 here. Then 4 can split into 2 and 2 2s. And then if I count 1, 2, 3, 4, 5, 6, so this means 2 is raised to the power of 6. So now we've got 2 to the power of x is same as 2 to the power of 6 in this case. And you can clearly see that we have got this common base now. So we've got the same base. So what this tells is that 2 to the power of x is same as 2 to the power of 6. So we can drop the bases and solve for the unknown x. So in other words, the value of x is 6 in this case. Example 2, it says solve 3 to the power of 2x plus 1 is equal to 81. So what we can see is here we've got base of 3. So we need to change 81 and rewrite as the common base 3 in this case. So we can do that by using the factor tree. 81 can be written as 9 times 9, so that's easy. And then I can split 9. 9 is written as 3 times 3. So we've got those 2, and then the other 9 is also 3 times 3. Now I've got the 4 prime factors for 81. So this is same as saying 81 is same as 3 to the power of 4. Because it's 3 times 3 times 3 times 3, which gives you 81. So we will substitute that back here. So 3 to the power of 2x plus 1 is now same as 3 to the power of 4, because 81 is 3 to the power of 4. So once we've got the two bases same, so in this case 3 to the power of 2x plus 1 is same as 3 to the power of 4. In other words, 2x plus 1 will be equal to 4. So we get that information from there, and then we solve for x. So I will remove this positive 1, goes on the other side, becomes minus 1. So 4 take over 1 equals to 3. So if I move that over, it simplifies to 2x is equal to 3. Then divide by 2 on both sides. You end up with the final answer, which is x is equal to 3 over 2, or 1.5. Hope this makes sense. I would suggest you can pause the video and try this yourself. What you need to do is you need to rewrite the bases as powers of a common base, and in this case the base we were after was 3, so we need to change 81 to base 3, and using factor tree we can easily get that. So 81 is 3 to the power of 4. Now if the base is same, we can drop that, and then we can solve for the unknown power. and it comes to 3/2. Thanks for watching. I'll see you guys in the next video.